For?
What's that?
What's your meeting for?
Oh, it's just an appointment, that's all. So, okay. That's right.
Talking about how terrible I'm busting up.
Okay, yeah, exactly. No. All right, so we're going to continue in the vein of integration, but we're going to kind of take a little bit of a turn right now. We'll bring it back into integration here in a second. So our new unit is going to really be kind of like a marriage of two concepts. This kind of concept, which is like slope fields and then differential equations, okay? So where does that word differential equation come from? Well, it's called a differential equation. Well, it's called an equation because there's an equal sign, right? A left and a right-hand side that are equal here. But it's a differential equation because within this equation are x's, y's, and then also a derivative of those things. So in this case, we have the derivative of y with respect to x right here. So this is a differential equation. Okay? It kind of mixes x's and y's and then derivatives of those things, too. All together in an equation. So you might be thinking to yourself, Mr. Whitmire, we've seen stuff like this, and we've never called it a differential equation before. Well, maybe. I think in the past, we would use implicit differentiation to get an answer like this, right? So we never called that thing a differential equation, but it was. Okay. So if you remember, this might be like familiar or not familiar, but we've seen stuff like this back when we did implicit differentiation. Okay. So anyway, we can actually graph this by hand. Our calculators don't do it without like installing a program, all right, which I don't have anymore, but I can ask Mrs. Gilbert and see if she has it. Anyway, we're going to graph these by hand. We can actually kind of see this. So this differential equation, right? So dy dx, remember, at its basic kind of at our basic understanding of dy dx, that represents the derivative, and what does the derivative represent? But a what? A slope, right? A slope. So this value, whatever we get for dy dx, is going to be a little slope, okay, a slope at a particular point. And so we're going to basically do a little t-chart here, plugging in some x and y coordinates right in here, and then those x and y coordinates we'll multiply the x times the y, subtract the x, and that'll give us then our slope at that particular point. So let's do an easy one here, and let's do the one, for example, at the coordinate 0, 0. All right, so at the coordinate there for 0, 0, and it might not be a bad idea here to kind of give ourselves an idea. Maybe I'll do like a little chart over here. Okay, when we first learn to graph things. So I'll give ourselves like the coordinates, and then I'll write like the dy over dx equals xy minus x over here. Just kind of help organize it, right? When you guys first started graphing things, you start with this like little t-chart. We're going to do the same thing for this. So let's start with the origin. Okay, 0, 0. That's one of the points there that we're going to try. Okay, so in this case, our dy dx, our slope at that point, is going to be equal to 0 times 0 minus 0, which is just what? 0. That's right. Okay, so our slope here, at this point, we should draw a small slope, like a tiny slope of 0. Now, why am I drawing a tiny slope? Why don't I just draw a big slope of 0 thing right here?
It's only at that instance.
Right, exactly. This slope for dy dx is only occurring at 0, 0. There might be other points where our slope is 0, but for right now, we just calculated for this point 0, 0, and so we're just going to estimate the slope, and we'll just draw in like a little horizontal line segment, like right like that. It's a little chunk of horizontal line like that. So there's our horizontal line segment right there. Okay? And believe it or not, like, this is a very typical kind of free response question, or part of a free response question, to like draw in these slopes like this. All right, so let's pick another point here. Let's go to like, I don't know, let's try 1, 1. Let's see what happens at 1, 1. Okay. So let's see here. So there's the coordinate for 1, 1. So now let's plug in that 1, 1. And we get 1 times 1 minus 1. So 1 times 1 is 1, minus 1 is?
0.
0. Ah, so the slope here at 1, 1 is also going to be a horizontal slope of 0. All right, so you can just draw a little horizontal slope there. All right. Let's see here. Let's try another point. Let's try 2, 1. Okay, so we'll go right over here to 2, 1. Okay, so let's see here. 2 times 1 minus 2. right? X coordinate was 2, and Y coordinate was 1, so 2 times 1 minus 2. 2 times 1 is 2, minus 2 is 0. Okay, so at 2, 1 also the slope is 0.
It would never work for
Okay?
something
And in fact, yeah, for all the 1 values, right, if when Y is 1, can we go ahead and just say that all the slopes are going to be 0? Because if Y is 1, then essentially it's going to be X times 1, so it'll just be X minus X. And X minus X just simplifies always to 0, right? So anything where the Y value is 1, we can just go ahead and say all those slopes are going to be 0. Okay, can we make any other generalizations like that? For example, what if we pick something here along the y-axis where the x coordinate is 0? What will our slopes always be?
0.
0 as well, right? Because it'll be 0 as our x coordinate, so it's 0 times y, whatever that is, minus 0. Well, it's 0 minus 0 then. So all these slopes will also be, excuse me, 0. Okay.
Can you do the same for the x-axis as well?
So for the x-axis, let's see here. For the x-axis, that means the y-coordinates would be 0, and not necessarily because it's, so the xy will become 0, but yeah, we could get some other values there too. So we can't, yeah, we got to be careful with that. So now let's just kind of like go, I'll pick one more point here. Let's pick the point like 2, -1, for example. Okay, just to show you that not all of these are going to be 0. But like at 2, -1, for example, we'll have 2 times -1 minus 2. So 2 times -1 is -2, minus 2 is -4. So our slope we want to draw here is at -4. And you might be like, well, Ms. Wilmeyer, how are we supposed to draw a -4 slope? Well, think about it this way. If I wanted to draw a -4 slope from this point, that means I want to go down how much?
4.
Down 4 and right 1, right? The slope here as a fraction is -4 over 1. So that means rise of -4, run of +1. So I could go down 4, right 1, and then just kind of like eyeball how that slope would be. Alternatively, instead of going down 4 and right 1, what other direction could we go? Up 4, left 1. So if I go up 1, 2, 3, 4, and left 1, okay, now I know my slope from this point needs to roughly be, you know, aiming towards that point up there. So my slope should be something like this, pretty steep. Okay, something like that, up through there. Okay. And so we'll just kind of then mental map some of the rest of these here. So for example, at 1, -1, so it'll be 1 times -1, -1, minus 1, so -2. So my slope here is -2, so that's like left 1, up 2, so it's going to be something like this. Okay. And then -1, -1, let's see here, -1 times -1 is +1. +1 minus -1 is 2. Yep, +2. It's the same change. So it's going to go kind of towards that point like that. So there's our little slope there. Okay, here at -2, -1, let's see, -2 times -1 is +2. +2 minus -2 becomes +4. So it'll be up, right 1, up 1, 2, 3, 4. So it's going to aim up towards that point. Okay, so there's those slopes. You can kind of see some symmetry here, right? Some symmetry. These slopes are just opposites. All right, let's do 2. So let's see here. At so 2 times 0 is 0 minus 2, so it's going to be a slope of -2. So something like that. And then at 1, it'll be a slope of, let's see here, 1 times 0 is 0, minus 1, so -1, so a slope like that. All right, and then -1 will be a slope of +1. And then -2 will be a slope of +2 in this case. Something like that. Okay, so we kind of getting like a feel for how the flow of this is going to go, right? It looks like it kind of like curves up, but then it starts to curve back down.
That's the parabola.
Okay, so it's like an upside down parabola there beneath this line. Okay, good. And now we'll go up to the top here. Let's go to like 1, 2. So 1, 2, x coordinate's 1, so it's 1 times 2, 2, minus 1, so 1. So it's a slope of +1. Right there, so a +1. And then 2, 2. So 2 times 2 is 4, minus 2 is 2, so it's a slope of +2. Okay, and again, a slope of positive 2, you can go up to right 1, but we don't really have any points there to aim for, but I could go down to left 1, so I want to kind of aim that slope towards this point right here. Okay. Let's see, 1, 3. So 1 times 3 is 3, minus 1 is 2, so a slope of 2. So again, I want to aim it towards that point down there. That's down to right 1, that's the positive slope there. And then 2, 3. 2 times 3 is 6, minus 2, 4. So let's see here, down 1, 2, 3, 4. So I want to aim it towards that point. Okay, like so. Okay, and then we'll do the same thing over here. Negative 1, 2. Negative 1 times 2 is negative 2. Minus negative 1, so it becomes negative 1 is the slope. And then negative 2, 2. Negative 2 times 2 is negative 4. Minus negative 2 is negative 2 slope.
Minus negative 2, wouldn't that be negative 6?
Well, no, but it was negative 4, because it's
Oh,
negative 2
yeah, yeah,
times 2, so
okay.
it's negative 4 minus negative 2, so it becomes positive, or negative 2. You're adding the 2, but it's negative 2. Let's see here, negative 1 times 3, or negative 1 and 3, so negative 1 is the x-coordinate, times 3 the y-coordinate, so negative 3, minus negative 1, so negative 2 is the slope there. Okay, and then negative 2, 3, negative 2 times 3 is negative 6, minus a negative 2 is negative 4 now, so 1, 2, 3, 4, down to there. Okay? And so you kind of get a picture here. It looks like if we kind of consider below this line right here, if we consider below this line, it looks like it's an upside-down parabola, right? The way the slopes are kind of guiding us. Okay? Up here, or not upside down, it's like a parabola faces, opens up downwards, right? If you look above this line, though, it looks like we're going to have what instead? A parabola that faces upwards, right? 'Cause it's going to kind of come down, bottom out, and then come back up. Okay? And that's the idea here, okay? So, letter B says, sketch 2 different graphs given that the solution passes through 0, 0, and negative 1, 2. So by 2 different graphs, that means we're going to do graph 1, okay, using the solution point 0, 0, and then we'll do graph 2 using the solution point negative 1, 2. So I'm going to do 2 different colors here to kind of differentiate between the 2 things, okay? And so what we're going to do is we're going to graph a solution to this differential equation that goes through the point 0, 0. All right? So to do that, we're going to look here right at 0, 0. So here's the point 0, 0 right there. That's where we're going to start. I put a big old point right there to just kind of show our starting point. Okay? Now, as I go to the right, what should I start doing from this point?
Go down.
I should be decreasing, right?
Mm-hmm.
So I'm going to start to decrease, decrease, decrease. And you don't, here's one thing I want to be careful of. You don't have to go through these points, but use the slopes to guide you. So as we're moving to the right here, our slope of 0 should be starting to decrease, right? We should have like negative slopes as we go. That's why we need to go down. So we don't have to go through the points, though, connect the dots or anything. Like I said. Okay? So, Anna, this is it for 12:15. I'll get to you in a second here. So we're just going to keep going. Anytime we run out of slope, so we can then just kind of like arrow and say, okay, it's going to go down that way. Okay? Is there any more of our graph that we could draw here?
Opposite side.
Yeah, as we go to the left, what should be happening? We should also be kind of going downward, symmetrically speaking. Okay, again, it does not have to go through a point here. In this case, it kind of like works out nicely that it does, so we'll just kind of draw it like that. So there's our solution there. If we know our curve goes through the point 0, 0, that's the solution for our differential equation. Okay? This thing is also called a slope field. You can kind of see why it's called a slope field, right? It's a field of different slopes.
I've seen these pictures in our book.
Yeah, and you're like, there's no way. It's actually not that bad, though, right? It's not too bad. Okay.
I think it's painful.
Right, just connect the dots.
It would just be
Whee! Yeah, so on a free response question, you won't have quite this many points to do. It would probably be, like, take out the outer ring, and maybe you'd have, like, 9 or 12 or something like that. Typically, though, it's not many more than that. And a question? Absolutely, yes. So this slope field is obviously unique then to this slope differential equation. Each differential equation will yield a different slope field, and then therefore also yield like different solutions too. Okay, different solutions and stuff too. Yeah, question.
So you say it works nicely because it passes through these points. How do we know it passes through those points?
Well, we're told that it does, and you will be given that as well. that it passes through the point 0, 0. I mean, oh, like you're saying, how do you know it passes the point? You're right, you
Yeah.
don't. But it kind of worked out that it kind of looks like it might go through those points, so you can just
Okay.
kind of use it as a
You can't really
guideline.
know, I guess.
Correct, exactly, yeah. Well, I mean, you will be able to know, once we are able to solve the differential equations, then you'll be able to determine whether, yes, it does or whether it does not. Okay? And we're going to learn about solving those later. -1, 2. In fact, we'll be able to solve one just like this. Yes, we will. We'll be able to solve one just like this, yes. So, all right, -1, 2. So now let's plot that one. So this is a different graph because it's using a different point, okay? You can think of this point kind of like, well, okay, let's imagine this. If I wanted to solve this differential equation, what that means is I have this thing as a derivative, and so in order to kind of solve it conceptually, if we want to get rid of the derivative, what do we have to do? Integrate. And so remember, so we're kind of like integrating here for a solution. When you integrate, what do you end up with? Plus c, right? You have that condition that we have to find that c value. So you can think of this as like, this is 0, 0. This is like, kind of like, okay, let's say this is one particular solution, okay, that goes through 0, 0. Another particular solution is one that goes through -1, 2. So -1, 2, that's this point right here. Okay? So if I start at this point and move to the right, what is this point telling me to do, behavior-wise? Go down. But I can see that as I move to the right here, I had better end up with the slope of what here?
0.
0. So I'm going to go down, but I'm going to like not decrease as much because I have to kind of bottom out because I need to get a slope of 0 on this y-axis. All the points on the y-axis have a slope of 0. So I have to like bottom out at some point. So maybe I can bottom out like right there. Again, this is like little Bob Rossi. You know, it's kind of like, where do you want the trees to go? You know, it's like it's your world, you know, kind of thing. But you still have to follow the slopes, right? Okay. You know, so and it's Monday, exactly right. So we're getting crazy here, all right? So there it is. You can just, you know, kind of like follow the slopes. Maybe I should have gone a little bit less steep, but you know what? It's okay. Mistakes, it's not a mistake. It's just we're just going to let it be. So there it is. All right. Now after this point, do I just stay flat the whole time? No. Yeah. What does it look like we're supposed to do here?
Slope up?
Yeah, slope back up. It's supposed to start increasing. So. And maybe because it's symmetric, maybe I should try and, you know, kind of like Bob Rossi here, we'll kind of make it like kind of be symmetric. And then we're going to keep continuing to curve up there, upward though, it's like a concave up kind of deal.
Concave up like a cup.
And so so you can see for a different point, because we started a different place, it results in a different kind of graph because of the behavior of the slope field. Question?
So why do we ignore like the slope of 0 after the point 0, 1? Like, because there's like a net greater increase in slope.
Yeah, as we move to the right here, we can see that our behavior, unless we're actually on this, as we move to the right, our behavior is going to be going back to an
Like
increase
a net
there.
Increase, I guess?
Yeah. If you look at that kind of area, it looks like it should be increasing. And it's also symmetry too, I would say, Austin. If you can look here, the slopes very, very, not obviously I want to say, but you can kind of see the slopes on this side are symmetric. So it's like, okay, we should probably start going back at some point then too. That's the idea. Okay? So, again, we kind of already talked about letter C here. Can you find the equation of either of the functions? Not just yet, but we could find it, again, using like integration and stuff like that. And again, we're going to look at that in a little bit. Okay? I don't know if we're going to do that. Okay, well, yeah, we could potentially do that here.
You got 7 minutes just to work.
Yeah, I don't think I'm going to have enough time to do that. So, all right, let's try another one here. So why don't you guys flip it over here. Flippity floppity around, okay? Okay. So, excuse me. So let's try this one. Okay, another differential equation, and so let's see. We would assume then, because the differential equation is different, that our slope field will probably be different as well.
Okay, so are these going to be
Calculator, non-calculator? Non-calculator, most likely.
so I just have to like
Do a lot of little arithmetic. Yep.
Well, you can like logic some stuff out.
Right, exactly right. So Austin, you know, and that's exactly right. So Ryan's looking at this, guys, and he's saying, like, this is a lot of points to, like, potentially plug in and find all these slopes. And he's right. It is a lot. But Austin had a good point here in that you can also get some shortcuts. For example here, if x equals 0, what will all my slopes be? Slope is 0, right? And x is 0 all along the y-axis here. So all these points on the y-axis, which have x coordinates of 0, will be a slope of 0 there. So that's pretty easy to do. Okay, can anyone come up with another generalization we could make?
With the y.
Okay, if the y-coordinates are 0, what's going to be true?
All 0.
All the slopes will be 0, right? It'll be 0 times x, which is the 0, divided by 2, still 0. So all the slopes on the x-axis will also have slopes of 0. Right, and now you really only have 8 points you have left to calculate there. Okay? And so then, and now calculate these slopes. These other ones, what's remaining. All right, so let's just kind of go through this. So again, we'll take the point maybe like 1, 1. Okay, and we'll plug that into our differential equation here. dy over dx equals negative xy squared over 2. So we'll get dy dx here equals, what is it, negative 1 times 1 squared over 2. If you're finding yourself having trouble with these, like, bless you, arithmetic, like the mental math calculations, write it out like this, and this might help you to just kind of be able to do the math. So 1 squared is 1, times negative 1 is negative 1, divided by 2 is negative 1/2. Okay, so I need my slope here to be negative 1/2, which means I need to go which direction for my slope?
To the left.
Yeah, so I go down 1, right 2, but I kind of don't really have a point there. I mean, you can kind of eyeball it if you want, or you can go up 1 and then left 2 and see, okay, so this point I have to like make my slope kind of like point in the direction of that point right there. Okay, for that little slope. Okay, let's try 2, 1. Okay, dy dx equals negative 2 times 1 squared all over 2. And so let's see here. 1 times negative 2 is negative 2. Almost right here, Mr. Drum. 1 times negative 2 is negative 2. Divided by 2 is then negative 1. Okay, so the slope here, I should have a negative 1 slope. So again, from there to there. Okay, that's pretty easy to draw that. Okay. And then 1, 2, I'm just going to do these mentally now. So it'll be negative 1 times 4, so negative 4 divided by 2, so negative 2 is the slope there. And then at 2, 2, okay, it'll be 2 squared, which is 4, negative 2 times 4, which is negative 8. Negative 8 divided by 2 is negative 4, so a slope of negative 4. Now here we really have to eyeball because we don't really have any points to go by, so it's going to be really steep. Okay, on the AP test, they're not going to like take a ruler out or a protractor out and say, this slope's not quite steep enough. Okay, you just need to kind of get the general guideline. Okay, if this is a slope of negative 1, this is a slope of negative 8. This one had better be much more steep, and then in the correct direction, obviously, going down from left to right. All right, and let's look over here then. I think we do have symmetry here again. So negative 1, 1, 1 squared is 1. Negative 1 is positive 1, so it's positive 1/2. So up 1, right 2, so to that point there. Okay. And then negative 1, 2. So 1, 2 squared is 4, so 4 divided by 2 is 2, so the positive 2. Okay. And then negative 2, 1. Let's see here. Negative 2 is 2, times 1 squared is 1, so 2 over 2, so a slope of 1. And then negative 2, 2. 2 times 2 squared is 4, so 8 over 2, so 4, slope of 4. So again, it's a really steep slope. And then, oh yeah, 3 was the slope of 0. Okay, so there's all of our slopes in the slope field. All right, everyone okay with how we got all those slopes there too?
Yeah, buddy.
We're good? All right, so then it just says sketch the graph of the solution that passes through the point 1, 1. So again, we'll use red here for that, just so we can kind of, contrast. Identify the point 1, 1. I'm going to draw a big old point there so I can see it real easily. Okay. And so again, the slope here is directing me as I go to the left. What's the slope directing me to kind of do?
Decrease.
Yeah, decrease.
Up to the left.
So I'm going to decrease.
Go to the right.
And to the right, as I go from left to right, I'm decreasing.
Okay.
And then, but it looks like as I approach this x-axis, it looks like my slope had better flatten out some, right? So it looks like I kind of need to like curve it up. Okay, so something like that maybe, because again, I don't want to, like that 0, I got to kind of bottom out there as I approach it, so it's going to go something like that. Okay. And then as I go from right to, yeah, point of inflection there somewhere, yeah. So as I go from right to left, then what should I do? So it looks like it's telling me to kind of go up, but then as I move closer to this y-axis, what do I need to do? I need to like make it a relative maximum there kind of thing, and then I'll start to kind of, again, decrease. And it looks again like we have symmetry, so we can kind of decrease in a very similar fashion to how we increased. And then again, we kind of bottom out as we get down to there. And then there's our sketch, Bob Ross style. Okay? Happy little trees and stuff like that. Happy little curves. Okay? And happy little slopes that we do. Happy little slopes. Okay? So what I would like you guys to do, because I have to run, but get out. Leave. All right, so I want you to finish example 2, example 3, which is basically just matching the slope fields to those differential equations that you're given there. And then also I want you to try example 4, numbers, or sorry, A, B, and C. You don't have to do the D yet because we're not ready to solve that differential equation just yet. I mean, we can, but I'm going to have you hold off on that. I don't want you to, like, do something I've gotten to. Yeah. For example 2, you're supposed to... Oh, we already did letter B. Oh, I'm sorry. I guess we did finish letter B. I'm sorry. So it's really just 3 then. My apologies. Yeah.
All right, well, okay.